In this video, we're going to look at a few more problems related to basic probability. First, we'll look at an example where we employ the general addition rule. Then we'll look at an example using the general multiplication rule. And finally, we'll look at an example that uses the conditional probability rule. For our first example, we're going to apply the general addition rule for OR events. At a children's birthday party, the probability that a guest will eat cake is 0.85, the probability that a guest will eat ice cream is 0.59, and the probability that a guest will eat both cake and ice cream is 0.52. What is the probability of a person eating cake or ice cream? The formula for the general addition rule for OR events states the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Applying the formula to our scenario gives us the probability of cake or ice cream equals the probability of cake plus the probability of ice cream minus the probability of cake and ice cream. The probability that a guest will eat cake is 0.85, the probability that a guest will eat ice cream is 0.59, and the probability that a guest will eat both cake and ice cream is 0.52. Therefore, the probability of 0.85 plus probability of 0.59 minus probability of 0.52. When we calculate this, we get a result of 0.92. We can convert this decimal to a percent and represent it as 92%. The formula for the general addition rule for OR events can also be represented graphically as a Venn diagram. For example, A is the probability that a guest will eat cake. B represents the probability that a guest will eat ice cream. Our overlapping region right here represents the probability that a guest will eat both. When working with Venn diagrams, it's always easiest to work from the inside out. So I know that the probability of both is 0.52. That's the probability that a guest will eat both cake and ice cream. Now, if the probability that a guest will eat cake is 0.85, and I know that my entire circle A represents the probability of eating cake, I can see that 0.52 is already accounted for. In other words, 0.85 minus 0.52 gives me the amount, the probability, that a guest will eat cake only. We do the same thing for ice cream. I know that the probability of a person eating ice cream is 0.59. I subtract the overlap region minus 0.52, and that gives me 0.07. To determine the probability or likelihood of a person eating either cake or ice cream, we simply take the sum of the three decimals, 0.33 plus 0.52 plus 0.07, which equals 0.92 or 92%. Let's now take a look at the general multiplication rule for AND events. Here's our example. A large grocery store chain reviewed its data from consumer purchases and found that 68% of its customers' purchases included milk. Of these customers, 27% also bought breakfast cereal. If a customer is selected at random, Find the probability that the customer has included both milk and cereal in the purchase. The formula we need to use for the general multiplication rule for AND events is the probability of A and B is equal to the probability of A times the probability of B given A. This vertical line in mathematical notation in this case means given that or such that. In other words, given that a customer is already buying milk, what is the probability that that customer is buying breakfast cereal? The probability of A, in other words, the probability of buying milk, is 68% or 0.68. The probability that a customer buys cereal, given that they're already buying milk, is 27%, or 0.27. So plugging these values into our formula, we get P, probability of 0.68 times the probability of 0.27. That equals 0.184, which we can rewrite as 18.4%. For this example, we'll be applying the Conditional Probability Rule. At a local high school, students were asked whether they favored a digital yearbook instead of a printed copy. 37% of the student population favored the digital yearbook. Seniors made up 21% of the student population. 5% of the students were seniors who favored the digital yearbook. Find the probability that a randomly selected student favored the digital yearbook if the student was a senior. Applying this formula is a lot less complicated than it looks. The formula states the probability of B given A equals the probability of A and B divided by the probability of A. If the probability of A is being a senior and the probability of B is favoring the digital yearbook, the probability of A and B, in other words, being a senior and favoring the digital yearbook, is 5%, 0.05. Dividing this by the probability of A, that is, the probability of being a senior, which is 0.21, gives us a result of 0.238. We can convert that to a percentage and rewrite it as 23.8%. The key word in this problem is finding the probability that a randomly selected student favors the digital yearbook if the student is a senior. In other words, given that the student was a senior, what is the probability that they're in favor of this digital copy of the yearbook? As you can see, the formulas sometimes look a little bit more complicated than they actually are. In this case, all we had to do was divide 0.05 by 0.21.